we're going to be comparing linear and exponential functions and making some observations. Okay, so this is called a linear function. Okay, and we've seen this, right? We've graphed this. We actually know what this is going to look like. We know that this is going to be a slope of y-intercept of 0, right? This is plus 0, and a slope of 2. So we actually already know what this looks like, right? This is not actually a mystery. But we're going to go through the process for linear. I'm going to do it pretty quick for linear. And then we're going to go through the same process for exponential, so you can see that we're really comparing the same things. Okay, so for linear, our equation that we're working with is y equals 2x. So look, I've given you x values, right? Your first x value is -3. So if I want to find what the y value is, I'm going to write 2 times the x value. 2 times -3 is -6. So here my y value is -6. So when my x value is -3, my y value is -6. And I'm going to just go through and do this look, and I'm going to stop even writing y, right? The y is 2 times x, so this is going to be 2 times -2. That's -4. So when my x is -2, my y is -4. Here I'm doing 2 times -1, that's -2. Okay, so my y value is -2 and my x value is -1. That's this point on the graph. So I'm going to graph these points in just a moment. Okay, here, but I'm going to just go down the row, and this is, right, 2 times 0 is 0. Okay, so I have the point 0, 0. 2 times 1 is 2. This is not really new information, but I'm going through this process because I want you to see that this is not new information. And then when I do it with exponential, that is where there's going to be, some new observations to make. Okay, but we can see, oops, this was 4 and 6, and now I'm going to do 2 times my x value is 8. So here my y value is 8. Okay, so if I go ahead and I graph these points, right, and I'm going to graph them over to the side. So I'm going to graph -3, -6. I actually don't have space for on the graph. Okay, but I'm just going to keep going. I'm going -2, -4, -1, -2. Okay, and I'm just reading these points down my table right here, right? And then I'm going to graph 0, 0, and 1, 2, and 2, 4, and 3, 6, and 4, 8. And, right, you can kind of see, look, that's not on my table, but I can see, like, where it's going, and it would go to 5, 10. Okay, so we can see that this becomes, when I graph it, a straight line. Okay, and if I were to keep going, that pattern would continue. Okay, so some observations. The graph looks like a line, a straight line. That is why it's called linear. And then look, the pattern in the table. Look, here's what I want you to look at. This pattern right here. Okay, and let's look at the positive numbers because it's easier to think about patterns in positive numbers. Look, what's this pattern? 0, 2, 4, 6, 8. What am I doing here? I'm adding 2, right? I'm just doing +2, +2, +2. Okay, so the pattern in the table is adding. And I will tell you, if I had done, for example, y equals -2x, the pattern would be subtracting, right? And remember that adding, if I were to add, say, a negative number, that would be the same as subtracting. So when I say the pattern in the table is adding, it would also be linear if we were subtracting. Okay, so now let's do the same thing with the exponential function. Okay, so, and I'm actually going to start, look, I'm going to start down here with the positive numbers and then work my way back up with the negative numbers. Okay, so I'm actually going to start right here. So remember, this is y equals 2 to the power of x, right? 2 to the power of x this time. Instead of 2 times x, 2 to the power of x. So now this is 2 to the power of 1. What's 2 to the power of 1? Oh, well, 2 to the power of 1 is just 2. Okay, so this point is 1, 2. Now this is y equals 2 to the power of x to the power of 2. Well, 2 to the power of 2 is 4. 2 times 2 is 4. Now, this is, remember the equation is 2 to the power of x. So this is now 2 to the power of 3. Okay, well, what does that mean? Remember, that means 2 times 2 times 2. So that's 2 times 2 is 4 times 2 is 8. Okay, and now 2 to the power of 4, that's this, right? That's 2 times 2 times 2 times 2. So that's 2 times 2 is 4, times 2 is 8, times 2 is 16. Okay, so this time, and you might be starting to observe a pattern already. Let's work our way into the negatives, and we'll go back to the pattern. Look, this is 2 to the power of 0. Anything to the power of 0 is just 1. Anything, doesn't matter. In this case, it's just the number 2. Okay, now look, this is 2 to the power of -1. What did we say negative exponents meant? Remember, what negative exponents meant is, oh, look, this is a fraction, and this 2 isn't happy up here. So what does this equal? This means that 2 wants to be down on the bottom. So 2 to the power of -1 is 1/2. Okay, look, this was 1, this was 1/2. Now, what about 2 to the power of -2? Remember, it's always 2 to the power of x. This time it's 2 to the power of -2. Well, that means this isn't happy up there. It wants to be down on the bottom, so it wants to be 1 over 2 to the second on the bottom of the fraction. And then 2 to the power of 2, right? This, we can simplify this. This is 1 over 4. Okay, and then look, 2 to the negative 3. What does that equal? Remember, we take it into a fraction. We say, oh, it's not happy up here. Let's put it down on the bottom. Okay, and then 2 to the third, as we know from down here, is 8. So this is 1 over 8. Okay, so let's observe the pattern first, okay? And again, look, like here, the negative numbers, it's like, I don't know, just a little trickier to see patterns with negative numbers. It's a little trickier to see patterns with fractions. Let's look here. What's this pattern? 1, 2, 4, 8, 16. Oh, we're multiplying, right? Look, this is times 2, times 2, times 2, times 2. And it actually works up here to 1/8 times 2 is 2/8, which is the same as 1/4. 1/4 times 2 is 2/4, which is the same as 1/2. 1/2 times 2 is 1. So here, the pattern in the table is multiplying. Okay, and I will tell you, right, like if I multiply, say, by a fraction, that would end up looking like dividing. Okay, so we're noticing right now the multiplying, but I'm just reminding you, ooh, this could end up looking like dividing. The same as here, we were observing adding, but remind you that it could end up looking like subtracting. Now, let's look what the graph looks like. Let's go ahead and graph these points. And I'm going to go ahead and I'm actually going to start, again, just like I'm going to start with the easy points. I'm going to start with 0, 1. So that's 0, 1 right here. Okay, and then I'm going to go to 1, 2. 1, 2, that's right here. Oh, look, it intersects with this line. Okay, I'm going to go to 2, 4. Oh, interesting. It touches this line again. Then I'm going to go to 3, 8. And then 4, 16. Oh, man, I'm all the way up here. 4, 16. Okay, now, so that's these points. Look, and I'm just going to kind of like circle these so we don't lose track of them, right? They were on the line as well. Okay, let's go back here. This point, -1, 1/2. So look, I'm going to, on the graph, sorry, I'm trying to be close enough that you can see. -1, and then I'm going to go up 1/2. So like here's 1, but here's 1/2. Okay, and now this point, -2, 1/4. So now I'm going to -2, and an even smaller fraction, right? Like this was like halfway up to 1, so 1/4 is like maybe here. And -3, 1/8. So I'm going now to -3, and I'm even closer to the line. Okay, and notice it's not 0, right? But I'm getting really close. This fraction is getting smaller and smaller. Okay, so I want you to see, I'm going to try to zoom out here without knocking this over. Okay, I want you to see what this graph looks like. It looks like a curve. So look, I'm going to come all through my points that I noticed. It happens to come through here. Okay, and then it goes up, 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 really fast. Okay, so it ends up going, it kind of starts off slow, and then and then it goes up really fast. Okay, and you can kind of think what the next number would be, right? If the next thing would be 2 to the 5th power, that would be 32, so the next point would be 532, it would go up even farther. Okay, so our graph looks like a curve. Okay, so notice it's a curved line. And then I want you to also just observe it goes up quickly, right? Well, whereas this line just kind of steadily goes up, this graph kind of, it curves, and then like, oof, it just kind of bursts up quickly. Okay, so that's just something to notice about exponential functions.